Welcome back to Truck Tech, everyone. You know, this show from Las Vegas actually occurred a few weeks ago, but it's really important that we show you what's going on in Aurora Innovation. You know, they're partnering with Continental. We're going to be able to talk with both Sterling Anderson, who's the Chief Product Officer for Aurora, as well as Jeremy McLean from Continental, about what's happening in terms of getting ready for what I refer to in the piece as big boy school in terms of the scaling of autonomous trucks. And this is something we hope you'll enjoy, so give it a watch. Here with Sterling Anderson, the Chief Product Officer for Aurora Innovation. Sterling, it's nice to see you in person. I know we've talked before.
We have.
Over video, but it's great to have you here. At CES in Las Vegas, you're here with Continental for a big reason, obviously,
That's
and we'll
right.
get to that in just a little bit. But the truck behind us, this truck, it represents what level of development are we at?
Yeah. This is the current pedigree of the Aurora Driver. So it's equipped with all of the Aurora Driver hardware and software that we expect to take to our Aurora Driver Ready milestone here shortly, and ultimately to commercial launch. So if you look around the truck, the sensor modules, the computer, the networking system have all been designed to operate in a without a specialist on board, with redundant componentry, as well as things like cleaning solutions. If you look up on some of these sensors, you notice there are these jets that provide an air knife or liquid cleaning. This is for operation in diverse weather conditions as well. So the Aurora Driver element of this has been designed to support commercial launch. The base truck platform is equipped with redundant actuators in support of some of our development work that we're doing right now, but it's not yet ready for that commercial launch today.
What we see here with the cameras and everything at the top, the LiDARs at the top, this is all ultimately what we're going to see when these take the road?
That's correct. That's correct. So this is the commercial ready Aurora Driver hardware kit.
Okay. And this is ultimately, and we'll talk with Continental, this is ultimately what you're having them build in terms of
an advanced version of it. So what we're working with Continental on, and the milestone we just achieved, is we've completed the specifications and architecture for the hardware that Continental is ultimately going to create at large scale. It improves on this quite a lot. So while this is it will support commercial launch. It's more expensive, obviously, to build it as we build it today. It also doesn't have some of the advances that we expect to be rolling in over the next couple of years together with Continental. So the phase we've just entered with Continental is over 2024, 2025, as we're doing the detailed design, testing, and validation of that kit for preparation in 2026 and 2027 for them to produce these at scale and introduce them on the manufacturing lines of our OEM partners.
And just to be clear, when they produce those modules, those Aurora Driver hardware kits, they will then be installed on production lines, or would that be a retrofit?
Correct. They're installed on production lines. This is really important. It's important to the industry that OEMs are backing and the entirety of the supply chain is backing, supporting, and providing that ongoing support for these assets at large scales. That's one thing that OEMs and Tier 1s have built to date. Continental has been phenomenal at that. These OEMs in PACCAR and Volvo also have a robust operation to both produce these and support them at scale and operation. And so yeah, that's an element of it, and Continental will be right there alongside Aurora in providing that ongoing service maintenance and support.
Well, certainly Continental has done many projects and products, you know, where their efforts are integrated into a product. This seems like not just an advancing, but this seems like the way trucks are built.
Yeah,
this is how
that's right.
This is how
that's
a truck
exactly
or a
right.
car is actually assembled. You make the automotive grade product, and then you integrate it onto a production line. Maybe it's a spur, maybe it's a main line, but
that's right.
It's done that way.
Yeah.
Let's talk a little bit about what we see here. If we could just walk around the truck, maybe
Sure.
just a little bit, you can point out some stuff to us.
Yeah. So what you see are some of these near-range pods give you visibility right around the truck. That's important, obviously, for a variety of reasons. The pods are placed in locations where they get visibility to what we need to see. So for instance, long ranges over top of the vehicles in front of the truck, it's really important that integrated pod that we worked with the OEMs to actually integrate deeply into the truck is there. as well as these side modules, each of which are designed modularly to allow for design for reliability and maintenance and serviceability. So one can swap those out if needed. But it's really important where they're positioned. So effectively what you're seeing here is 14 cameras, 3 of our proprietary First Light LiDARs that see a very long range, instantaneous Doppler, and interference immunity, 2 mid-range LiDAR, what you see here in blue, and then 3 of these short-range LiDAR for seeing right around the truck. 5 radar, imaging radar are located around the truck, and then inside the truck you'll see our proprietary computer networking system, all designed, as I said, for commercial launch.
One of the things that trucks have a real issue with, all trucks, is damageability. You know, when they go into a dock or they go wherever they're going to go. Now, I realize that this is a hub-to-hub operation, principally, and that's how you'll do it. But I see a lot of things that, for lack of a better word, kind of stick out. Are you concerned about that in terms of damageability when you actually get on the road?
It's a good question. That was important for purposes of visibility. So you'll notice it's not an accident that this gets at least as good of view along the sides and behind the truck as your side view mirrors do for a human driver. It's important that you have that visibility. And so from that perspective, the prominence of some of these sensors were required to get that kind of visibility. As it relates to service and maintenance of these trucks, you mentioned hub-to-hub. That is how we're initially launching, but we're going to be, in relatively short order, beginning our endpoint operations as well. So we'll be, when these trucks in particular are owned by private fleets, by carriers, they'll be operating them without having to stop at Aurora terminals at all. And so we do expect that, some need for kind of serviceability on site, and that's what they've been designed for. So in the event that any of these were damaged for any of a variety of reasons, they've been designed so they can quickly be swapped out, quickly recalibrated, and quickly back on the road. We recognize that uptime for these trucks is not only has to be on par with, we believe it can be much better than human-driven variants, right? And the reason for that is obviously the driver availability is much, much higher, unconstrained by hours of service or other constraints that require them to get home.
Well, and you do pick up the advantage of not having to deal with HOS or hours of service. Right. But if the vehicle was down for servicing or whatever, but you're suggesting that most of these are pretty easily swapped. And
that's right.
You know,
now
does any of this sort of break away, or is it all pretty much,
Nope, they're not breakaway. We certainly don't want them breaking away inadvertently on the road.
Sure.
But they are a relatively quick swap. Okay. And that's a part of that consideration is actually for manufacturability as well, because when you can bring them in as a module from, for instance, Continental, and have an assembly line with a takt time of 4 minutes, you got to get that thing on, connected, and ready to go quickly. That the design elements that support that also support rapid interchangeability in the field.
You've talked about 2024 as a commercial launch. I think I've heard 20 trucks. Is that accurate?
Yeah, it's about 20 trucks. We're going to start deliberately small.
Okay.
Yeah.
And what about, a couple of years ago, there was a lot made of the Pilot, the Too Simple, which is now not in the market, in the U.S. market anyway, did its pilot run of 80 miles. How will you start, or have you already started with, sort of driverless testing? I mean, have you actually done that?
Yes, we've tested these regularly.
No press releases.
No press releases. We've tested them without any human on board on test tracks at speeds up to highway speed, and down to 0. That's an important part of our development. One of the things that's really important to us, and we've said this for 7 years now since we started the company, is we practice as we'll play, and we are not interested in the flashy demos that ultimately are less meaningful for the industry or for the product. When we launch, we're launching for real. No chase cars, no lead cars, no escorts. The kind of things that you've seen in the industry to date have been, as far as I can tell, demonstrations, R&D demonstrations. We can talk about the responsibility or not of doing them that way. But to your question, yes, these have driven without humans on board, but we do it in controlled environments, and we do it as part of our rhythm of preparation. But you're right, no press releases about those.
Okay, I didn't think so. I didn't think I missed it.
No, you didn't.
As far as the safety case that you were talking about, I mean, you're feature complete. We know that, both hardware and software. Is that correct?
That's right.
Both. All right. So the safety case then is just validating what you've got
That's right.
and continuing to validate.
Exactly right.
Is that right?
Yep, that's right. So
Very
it's the collection of a combination of empirical and analytical data that support our safety case, which I'm sure you've seen, the safety case framework that we publish publicly, and all of the claims and required evidence to confirm that this is appropriately sufficiently safe for public roads.
Right. I'm with Jeremy McLean. He is the head of systems and software mobility. Systems and software
business
for autonomous mobility.
That's right.
At Continental. Now, Continental, of course, is among the largest suppliers in the world.
That's
what
right.
you're doing with Aurora is essentially what they do in big boy school, where you but you harden the hardware and the software for integration at assembly plant level.
That's right.
That's how trucks and cars are done.
That's right. Producing at scale. That's the most important thing. If we want autonomous trucking to be a big thing and to be successful, we need to be able to produce it at scale. And that's one of the things that we bring to the table here, together with Aurora, is to be able to bring the industry's first automotive grade, serviceable but also scalable autonomous driving solution to the market. Yeah.
Take us through how that happens. I mean, you've got lots of experience doing this with passenger vehicles.
That's right.
Certainly, is this the first real truly autonomous truck project that you've had?
And we've done a lot of projects throughout the years. I mean, the first autonomous driving project that we did was more than 15 years ago. We actually had our first autonomous driving test vehicle licensed here in the state of Nevada back in 2012. Yeah, so more than 10 years ago. So we've been working in this space for a really long time. We did a lot of work in passenger cars. We've recently done also a lot of work in trucking. But what makes this unique is the ability to really have it scalable ready, having it ready to scale, having it ready to hit the roads, more than just a kind of development or demo project, but really to hit the roads in a big way. So that's the value that we bring together with Aurora.
What we've seen in the autonomous trucking space in the last year specifically has been sort of a winnowing out of companies that looked real promising and maybe financially ran out of runway or whatever. Yeah. Aurora's not shape.
Certainly not.
So you've got a couple of companies right now, maybe Kodiak being the other, that are taking slightly different approaches to getting to market. This idea, though, feels like something that is for the long haul, literally, not just freight hauling, but the long haul in terms of having something like this.
Absolutely. You need, the ability to qualify automotive grade hardware, ship that automotive grade hardware in kits to the manufacturer, to the truck manufacturer, have it built on the assembly line, qualified on the assembly line, and then sent to the fleets to be deployed autonomously by Aurora and by the Aurora driver is something which is very unique. Yeah, that's something that we believe is industry first in this partnership.
Well, Aurora will put 20 trucks on the road this year. That will not involve sort of the same integration work. Those will presumably be upfit, whereas these will actually, you'll ship the kits over to the manufacturers. Right. How does that integration with the manufacturers work? I presume you're talking to them already about sort of how that works, whether it's done on a spur line or whether it's done on the main line.
Yeah. So I mean that's one of the things that we do very well. We do every day. We've done it for decades. Is produce hardware, electronic hardware, which is then integrated directly into vehicles on the assembly line. So of course we're working directly with Aurora and the manufacturers to specify what are those interfaces, what are the production qualification requirements in order to make sure that is done ahead of time, that is fully seamless, and we're able to build those trucks at scale when the time comes in the 2027 timeframe.
The Aurora approach of having two non-exclusive but partners nonetheless in Volvo and in PACCAR, Peterbilt in this case, really allows them then to work with that redundant chassis where you bring then the driver to that.
Right.
You've had about a year's worth of working with Aurora, maybe a little longer.
Correct. Yeah, we've of course we've been working on this partnership for a long time, but we signed and announced the partnership back in April of 2023, and we just passed a big milestone back in September, which was the freeze of the design and the architecture for this system that will deploy scalable in 2027. And that was a big milestone because now we're able to really lock that in and start all of the work that's necessary to make sure that that's really ready to scale and truly automotive grade by 2027.
Now you're investing, I think it's $300 million, maybe a little more, in New Braunfels, Texas, for a plant. You'll do other things at that plant besides this, right?
Yeah, of course. Yeah. The plant's already running. The plant opened a year and a half ago or so, and it's producing many different products already. So the third, fourth, fifth generation of our radar technology, industry-leading radar technology, already being produced there. And all of the different hardware that we'll deliver to the manufacturers as part of this Aurora driver autonomous kit will be produced either at New Braunfels, Texas, or at a global network of our manufacturing plants. And the New Braunfels, Texas plant will play a very important role in the final assembly, but as well as in the overall service concept, especially because it happens to be at the heart of the deployment area, which is, of course, the southern United States and Texas.
Right. Obviously, Texas is where this all gets started. They've been very open. The state has been very open to autonomous development, and that sort of makes it work. Let's talk a little bit about service. You've mentioned it a couple of times. What sort of service activity will Continental be involved with these?
Yeah. So we don't only deliver the hardware, but we're responsible to maintain the hardware throughout the life of the truck. So we talk about 5 years, 1 million miles lifetime, and the ability to keep that autonomous driving kit operational throughout that, of course, requires a couple of things. It requires that we're able to monitor the performance of the hardware while it's driving. So we do that via the Aurora beacon services. So we pull data from the hardware, we monitor its performance, and we're able to then schedule preventive maintenance, servicing, cleaning of the sensors, inspection of the sensors, maintaining of the sensors, and even then removal and replacement of the sensors or the pods. You see on the truck we have these sensor pods. I think Sterling explained it earlier. And serviceability is a really important aspect of keeping trucks on the road. I mean, the whole value of an autonomous truck is, of course, to keep it on the road and to have it hauling freight. So to be able to bring a truck in that needs to be serviced, and if one particular sensor needs to be replaced, it may be easier to remove the entire sensor pod, replace it with a new sensor pod, a sub-assembly, which is already qualified, and get the truck back on the road so that other pod can be serviced, inspected, and then maybe even refurbished to put back into the operation.
So to be clear, you'll have a group of service techs that will do this?
That's correct.
And they'll be done where?
At different terminals throughout the deployment area. Okay. Yeah.
But they'll be Continental trained or Continental employees that are...
Continental trained for sure, and then they'll maintain that hardware over the life of the truck. That's right.
Last question. It's interesting because, there's drivers as a service, there's truck as a service, there's all kinds of different models for how the revenue is generated. How do you get paid for what you do?
Sure. So this particular model we call hardware as a service. So I'll walk you through a little bit the way that scenario will work out. There's a fleet which wants to deploy an autonomous truck via the Aurora driver, contacts Aurora and asks them if they're able to support them from a particular route, a lane from Dallas to Houston as an example. Aurora authorizes that, asks them to order an Aurora-equipped driverless truck from one of the partner manufacturers. They then order the kit from us. Continental pre-assembles all of the pods, all of the hardware into a kit, ships it directly to the manufacturing plant. That truck gets manufactured on the assembly line, delivered to the fleet, and then gets enabled for autonomous driving services. Then every mile that truck is hauling freight autonomously or driving autonomously, there's an exchange of money, so a pay per mile service, which then goes to Aurora, and a portion of that per mile fee then comes to Continental as part of the hardware as a service deployment.
Is that new? Is that a new way to get your money?
That is certainly new for us and for the industry, but we do believe that's really one of the exciting things about this partnership and about scaling autonomous trucking. Yeah, so to be able to really do that with new business models to make sure that we're able to leverage the value that we all can bring as partners to the table, and to be able to really truly scale it and make it affordable for all of us, and of course it's lucrative as well.
Sure. Well, Jeremy, thanks so much. I appreciate this. Great explanations, and I think the audience will appreciate it too.
Nice to meet you.
Good to meet you.
All right.
we hope you enjoyed that episode with Sterling Anderson and Jeremy McLean. The idea of what Continental's up to is, yes, they're going to put autonomous trucks in commercial use this year, 20 of them later this year. They're already testing them without drivers in closed settings. But here's what's special. These guys are looking at the future in terms of scaling up autonomous trucking. The way to do that is to work with one of the world's largest suppliers, get those parts hardened so that they can be assembled onto an assembly line in an assembly plant. That's how vehicles are done, and that's what Aurora, with the help of Continental, is working. Thanks for watching.